guess that's the projector day. Okay. Let's start from the current slide. And the first thing I want to know, any questions on anything we've done up till now? All right. We're still in Chapter 13, which are exponents and polynomials. And 13.5, which is what my mark was, we're beginning today. We'll use 0 as an exponent. These are our objectives. Use negative numbers as exponents. And by the way, with negative numbers as exponents, they're no longer polynomials. You cannot have a negative exponent as a polynomial. So we're extending this beyond polynomials here. We'll use the quotient rule for exponents. And Anitra, right? And David, right? I'm sorry. Ears are plugged, so you won't be able to hear me in class. Okay. All right. David, right? David, right? Okay. Use the quotient rule for exponents, and then we'll use a combination of rules. All right. Something that's true from now and forever. For any non-zero real number a, okay, a to the 0 is 1. For any non-zero real number a, 0 to the 0 is not defined, okay? You just can't do it, okay? But any other number, 0.000000001 to the 0th power is 1, okay? Any non-zero real number raised to the 0th power has a value of 1. For example, 17 to the 0th power is 1. 17 million to the 0th power is 1, okay? 1/10,000,000th to the 0th power is 1. Negative 15,000 to the 0th power is 1. It doesn't matter what the number is, as long as it's not 0, something to the 0th power is 1. Which, you can also, once we start throwing variables around, x to the 0th power is going to be 1, okay? So even with a variable in there, it's going to be 1. Anything to the 0th power is 1, as long as we assume that thing is not a 0, okay? That is the only thing that we have to watch for. So here's example 1, okay? Evaluate 38 to the 0th power. Anyone got a calculator handy? No. Huh? No. What is it? You don't need a calculator. It's a joke. It's what? I'm sorry? No, 38 to the 0th power. 38 is not. That's 1. Everything. Okay, I guess I didn't say it loudly enough or often enough. Everything to the 0th power is 1, unless it's 0 to the 0th power, and that's understood. That's not defined. All right. And, oops, they wrote right on top of me, didn't they? Okay. Everything to the 0th power is 1. Okay. How about negative 9 to the 0th power? 1. How about negative 9 to the 0th power? Say again? Negative 1. Because you do your exponent first, please excuse my dear Aunt Sally. So 9 to the 0th power is 1. The negative sign's in front of it. That's a negative 1. Does everybody see that? Okay. That's a sneak up and bite you one. Okay. That's a negative 1 times 9 to the 0th power. 9 to the 0th power is 1. Negative 1 times 1 is negative 1. All right. We got there. And Greg Troy got there too. Okay. Good deal. Anyone else come in since I called it? Okay. All right. How about x to the 0th power? What is it? 1. Okay. Anything to the 0th power is 1, even a variable. You just have to understand that a variable can't be 0. So that's 1. 5x to the 0th power. Well, you do your exponent first. X to the 0th is 1, then multiply 5 times it and you get 5 exactly. Okay? Remember, do the exponent first, then multiply or divide or whatever it's asking for. 5 times 1, which is 5. Got it? See it? All right. How about 5x to the 0th power? Second? Oh, let's see. 5x is 5x. Raise anything to the 0th power is 1. That one is 1. That one's 5, the other one's 1. Okay? That is 1. I thought someone was coming in. I guess not. Does everybody see that? It's a little tricky, but it's true. Truly tricky. Okay. All right. Now that's the equivalent to the 6 that you see under example 1 in the text. Okay? So please go home and do those right away. And turn around and also do the ones in the sidebar. The sidebar, the gray, what do you call it, the marginal ones, they have their answers right there. The others you have to turn to the back of the book to get them, okay? Well, the examples, they give them to you, the answers here. So I think there's a caution coming up. Let's see if it's here. Nope. The caution was referring to things like this. That if you have a minus in front with no parentheses or anything else, always do the exponent first, then negate. That's the time when you'll get something else. Same thing down here when you have a number in front of it. Always do the exponent first, then multiply. And that's why you come out with things other than 1. The rest of them are all going to be 1s. Okay. So, let's go to negative numbers used as exponents. Okay? Now, here's the rule. For any non-zero real number a and any integer n, if you raise a to the minus nth power, okay? Now, I have a silly way to refer to it, okay? That moves the a downstairs and moves the exponent, okay? If this is in the numerator to begin with. If this was in the denominator to begin with, it moves it upstairs and loses the negative sign. So a negative sign moves it across the division line, and you lose the exponent with it. That's how I look at it. If that's confusing to you, just use the rule, okay? It works, okay? So, what would 3 to the minus 2 be? Second? A little louder. Okay? If that were a positive 2, you'd be absolutely right. No, wait, no, you wouldn't, would you? No. The minus sign doesn't move in front or anything. This minus sign with the exponent only deals with directing the exponent where to go. It doesn't translate to be something in front of the number. So no, that negative stays there until you do something with it. What does that negative 2 tell you to do? Move it downstairs. So that would make it
a positive.
Say again?
A positive.
Okay, this number is positive. There's no sign in front of it. So that hasn't changed. What the minus sign does in the exponent is move it downstairs and then make it positive. If that's what you're meaning, you're absolutely right. That'd be 1 over 3 squared. So you move it downstairs, lose the minus sign. Now, if there was a minus sign out here, you don't lose that minus sign. You only lose the minus sign for the exponent. And what is 1 over 3 squared? 1 over 9. Yeah, exactly. Does that make sense? Okay? The minus sign with an exponent moves it across the division line, and then you lose it. If that's what you were saying, you're absolutely right. If there's a minus sign in front, That doesn't change. The minus sign stays in front. Okay. Now, I bet you, oh, here's Austin. And there you are. Okay. Now, here's example 2. Simplify by writing with positive exponents. Assume that all the variables represent non-zero real numbers. Because guess what? If it was a 0, you can't move it downstairs, okay? You can never, ever, 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 ever divide by 0. So what would this be? We're basically just going to rewrite it. I'm going to write it under here, hoping that they're going to do their writing up there. What would that be? What would that represent? 1 over 9 to the 3rd power. Exactly. Now, if you want to multiply that out, that's 9 times 9 is 81, times 9 is 729. I don't care about it, but yeah, I don't think they'll do it. It's 1 over 9 cubed. All they say is write it without using positive exponents.
So on our quiz test, we'll leave it like that?
Yes, and then I'll mark it wrong. Nah, no, I'm just kidding. Okay. No, if it says, notice what it says, simplify by writing with positive exponents. If you actually multiply that out, you wouldn't have any positive exponents. All they're wanting you to do is move it downstairs and lose the negative exponents. Right? Okay. And that's exactly what they did. Let's see if B's got, oh, they did take it the other step, didn't they? 1 over 729. Their instructions said to do that. They took it one more step. If it says write it, simplify by writing with positive exponents, then evaluate, that would be doing the then evaluate. Okay. All right, the B. Ooh, what are we going to do with that? You tell me. And there's several ways to go about doing it. What do you see there? Okay, say that one more time. Your frequency and my hearing are not matching well. Say it one more time. Okay. This negative, you're going to put it in the denominator. Is that what you're saying? No, that's not what you said. Huh? That is what you said. Okay, so you move the 1 over 1/4 to the negative, to the positive 3 power. Is that what you said? That's correct. You certainly can do that. Okay? Now, like I said, there's several ways to do this one. This is 1 over 1/4 cubed. That's exactly right. Now, that's not very simple. Okay? So what would you do to continue that? Second? No, a cube is a multiplication process. What's that? Okay. I don't know if this is what you're meaning, but it certainly, this is true. 1 over 1 cubed over 4 cubed. Is that what you meant? That's not what you meant. But you're okay with it. Yeah, that's true too. Okay? And what would that be? I'll do the 1 cubed part. That's 1. What's 4 cubed? Anybody know? 64, you said? Yes. Okay, 64. And what is 1 over 64? Well, this is a division line, isn't it? So that's the same as 1 divided by 1 over 64, right? And how do you do division of fraction? 1 times, say again? 64 over 1, which is 64. Very good. Now, yuck. This chair grabs my thing and tries to pull it to the floor. Nasty thing there. Okay, so that's certainly one way to do it, and that's how you got there. Let me show you if you had done a step similar to this at the very beginning, what would have happened. this would have been equal to 1 to the negative 3 over 4 to the negative 3, right? Okay. Now, what's 1 to the negative 3? 1 over 1 cubed, right? And what's 4 to the negative 3? 1 over. So this one's already in the basement. Move it to the first floor. 4 cubed, right? And now you look at that and say, what's 4 cubed? 64 over 1 cubed. 1, that's 64. So that actually is the easier way to do it once you realize you can do it that way. But there's, like I said, there's dozens of ways to do it. Here's the other way. Now, this may not be as obvious to you, but this is certainly true. If you move these, flip them both, then you lose the minus sign. So that would have been, just in one step, you did 4 over 1 cubed, and 4 over 1 is 4 cubed is 64. So that's a really quick way to do it. And that's legal to do. If you have the minus sign on a fraction, just invert the fraction and lose the minus sign. See that? So there's all sorts of little ways to do this. And it's okay to do it any way you want to, as long as it's correct. Don't come up making some new rules for me that don't always work. Okay? I make the rules. You obey them, right? This is, never mind, I'm just kidding. All right, I think we've just about wasted all the used all the space we can on that one. Let me erase these, and let's see what they do. Okay? Which way are they going to do it? Ha! Look at what they did. They took the easy route. They inverted this and lost the minus sign, which is legal in most states, okay? And what's 4 over 1? 4. 4 cubed is 64. Look at that in 2 short steps. Okay? But every way that I understood you saying would have been correct as well. Okay? Let's see what the C says. Ha! So what are you going to try on this one? What would you do? First step. Say again? Flip them, okay? And that would be 3 over 2 to the 5th power. Anyone know what 3 to the 5th power is? Well, 3 times 3 is 9, and 3 times 3 is 9. So 3 to the 4th power would be 81. Multiplied by one more 3 is 243, right? So that would be 243. And how about 2 to the 5th power? 2, 4, 8, 16, 32. Yes, 32. And that's about as simple as you can go. Don't try to see if we can reduce that, because these have 5 factors of 3, 5 factors of 2. There's no common factors. That's it. Improper, but okay. You don't have to have it. Yes? Say it again.
We have to reduce them.
Do we have to leave it like that? Is that what you said? Yeah. You don't have to. You could divide into it if you wanted to. But perfectly okay to leave it like that. Yeah.
Do we have to reduce them on the test?
Oh, do we have to reduce them? Not unless it says to. If it says write your answers with no improper fractions, then you would have to. And if they don't say that, assume you don't have to. And you know what? Assume me. Never mind. We won't go into that. Okay, you probably do know what it means. Okay, but we'll be okay. If you have a correct answer that has done everything the problem called for, even though it's not the one in the key, I give you credit for it. But if it says simplify by writing with positive exponents, and you wound up with a negative exponent in your answer, you haven't done everything. It may be a correct answer, but you haven't taken out all the negative exponents. So then you might lose a point or two. If it's the correct answer, you're going to get the majority of the points. But if it's the incorrect answer, you're not going to get the majority of the points, okay? But if you got a correct answer but haven't done everything they said, I only take a few points off. But if you've done everything they said, it's a correct answer, even if it's not the one on the key. I always evaluate and say, yep, that's okay. We'll go with that. So let's erase this and see how they did it. Ha! They did it exactly like y'all did. They inverted and lost the minus sign, and then they got 243 over 32. Very good of them. Any questions? And they left it that way. That's their final answer. So yeah, you have precedent now. Any questions? Okay. Notice that we changed the base to its reciprocal if we also change the sign of the exponent. Yeah, that's what we did. You noticed that, didn't you? Okay, yeah, good deal. Okay. That was example 2, right? See if there are any others in example. Yeah, here's some more. Ah-ha-ha-ha. Simplify by writing with positive exponents. Assume that all variables represent non-zero real numbers. But here we got something else to do. What in the world is 6 to the minus 1? One more time. Do not take this negative sign and put it in front. You don't do that. All that negative sign does is tell it where to go. 1 over 6 minus, second, 1 over 3. Excellent. Okay. Now, we can take that a little bit further, can't we? Yes. Okay. Now, that has become from a negative exponent problem to a fractional, subtraction of fraction problem. What do you do to subtract fractions? Common denominator. What's your common denominator between those two denominators? 6. Not 2. 6. 2 isn't even up there. 6 is something that both of those will go into. So this would be 1/6. That doesn't change. Minus how many 6 is 1/3? 2/6. There's where the 2 comes into play, right? That's what you were meaning in the first place, right? Yes, it was. Okay, I believe you. Okay, and what does that give you? Say again? A little louder? I hope you said negative 1/6. There the minus sign is in front. But that minus sign had nothing to do with those. It had to do with this one. That's what made it a negation sign. These were just telling the numbers where to go, above or below the denominator, the dividing line. So negative 1/6. Does everybody see that? Any questions on that? Let's see how they did it. That would be 1/6 minus 1/3, which is 1/6 minus 2/6, which is negative 1/6. Look at that. They lined up right with us, didn't they? They're copying us, okay? They can't do it without us. Okay, so carry on. All right, let's see if they have an E. Ah, here's an E. What in the world does that become? You tell me. All right, wait just a second. Let me get Courtney here. Anyone else come in? Okay. What would that become? Say again? Why did you move the 3 down? Well, if that were in parentheses, I would have. If that had a -1 by it, I would have. But this is just a 3. It's a happy little 3. And it doesn't want to move anywhere. Huh? 3. Okay. Okay, you could. Okay, yeah, you could write it that way if I'm hearing you right. 3 over 1 times 1 over x to the minus 4. Is that what you were saying? Probably not. Okay. Okay. But that is true. Okay. So 3 over 1 is still 3. And what is 1 over x to the minus 4? Say again? How did you do that? When you move it upstairs, all you do is lose the sign. X to the 4th. Got it. You're like a dentist, but you got it. Okay? Does everybody see that? Let's clear that and see how they do it. Huh. I wouldn't have done it this way, but it is okay. It's 3 divided by 1 over x to the 4th, right? This is the dividing line, and this x to the minus 4 becomes 1 over x to the 4th. Okay, now that division, then, I'll do it down here, that's the same as 3 divided by 1 over x 4th, right? And then how do you divide fractional forms? Tell me. Times x to the 4th over 1, which would then simply be 3x to the 4th. Let's see if that's how they did it. Oh, look at them. They wrote it down there. But yeah, it's fine. I'll erase mine. I was trying to write where they wouldn't, and they keep changing it on me. Okay. And that is 3x to the 4th. See, this one does not have a negative exponent, so leave it where it is. Okay? We only change those with negative exponents. Okay? Nadia was thinking I wasn't going to show up early today, didn't you? Okay? I did. Just to get out of the meeting. No, I mean, I didn't say that, did I? Okay. Not out loud. So there's E. I wonder if we're going to have an F. We're doing example 2. It's similar to the ones on the bottom of page 882 in chapter 13. And the top of 883. Let's see if they have some more up there. No, they don't. Okay? So do you want to go back and do a few more like they have? So we just did one like that. We did one like G. Let's do one like H. Well, let's do H from the text. Yeah. 1 over x to the minus 4. That one's pretty easy. What is it? Say again? X to the 4th. Exactly. Move it upstairs, lose the sign. Okay? Good deal. Okay? Let's do one like, let's do I. Okay? I is, well, I don't know why I wrote that down, x cubed times y to the minus 4th. What would that be? One more time. Yeah, so can you. That's a, okay. Are you saying something? No, that's a G. No, Y. You're trying to confuse me, aren't you? That's a Y. Okay. X to the 3rd, Y to the minus 4th. Okay. Making fun of my writing, that loses lots of points, by the way. So count yourself in negative territory right now. Way negative. Okay. I can't get my pen to come back. Is that better? No, you don't think so. Okay. What would that be? It would be what?
X to the 3rd, y to the 4th.
Okay, say that one more time.
X to the 3rd, y to the 4th.
Oh, you just throw away the minus sign. Who needs it anyway? It's just a little bit of space there. I don't think so. Okay, you got x cubed. That stays where it was. Say again? I can't hear you. Oh, dividing line. Y to the 4th. Perfect. That's it. Only the thing with the negative exponent moves. The one with the positive exponent stays. And since you don't see a dividing line, assume that's all numerator to start with. So that's what it becomes. Any questions about that? Okay. I want to do one more. Okay. I don't think they've done one like it. Let's just do it. They sort of have done one like it, but let's do it anyway. What about negative 3 to the minus 2. What would that be? Okay, I see a 9. A negative 9. Really? Okay. Now, written this way, don't do a thing with that minus sign yet. Deal only with this part. What would that be? Okay, a negative 1 over 3 squared. Now you got it, and what's that? Negative 1/9. Do you see that? Y'all been wanting to do things with the minus in front, so I wanted to put one there. You don't do a thing with it, just deal with that and keep the minus in front because it doesn't get affected by the exponent at all. Okay? Now, oh my goodness, if I had looked ahead, which I didn't, admittedly so, look at this caution. Using negative numbers as exponents. Caution, yellow, caution, okay? A negative exponent does not indicate a negative number. It indicates the exponent's a negative number. Negative exponents lead to reciprocals. You reciprocate. If it's upstairs, move it down. If it's downstairs, move it up. Keep the exponent, just lose the sign when you do so. So, a to the minus n, I don't have anything down here. That is 1 over a to the n. Okay? What? I mean, this is 1 over a to the n. And what's negative a to the minus n? Negative 1 over a to the n. You move the base downstairs, lose the negative exponent, that minus sign stays in front. Okay? So, what would this one be? 2 to the minus 3 is 1 over 2 cubed. And what is 2 cubed? What is it? 2 times 8. 2, 4, 8. Yeah, double every time. 1 over 8. How about this one? Negative 2 to the 1 over 2 cubed, which is negative 1/8. Perfect. Okay? Now, I guess they didn't do this because they were going to do it over there, but it seems like to me they should have. All right. Any questions on that? Okay. There's your caution. Now, using negative numbers as exponents, changing from negative to positive exponents for any non-zero real numbers a and b, and any integers m and n. Okay? Now, notice they said any integers. Integers can be positive or negative, right? So you may have an m that's already negative, and you're going to negate it and make it positive. So you have all sorts of things that can happen here. But if you don't know what it is, positive or negative, you just know it's some number m. Then this moves this to the downstairs, this moves this one upstairs, and both of them lose the signs of the exponent. Not the sign of the number, just the sign of the exponent. Okay? Now this one, see, they're telling you this now after we've already done the examples. Okay? A over b to the minus m is the same as flip those, b over a to the positive m. Okay? Now, how about this one? X to the minus 5 over 2 to the minus 4. Now, what do you mean by that? Okay, you can do that only if you have the same basis. These are not the same basis. So what does that become? Okay, the minus exponent here sends it downstairs. So that becomes something over 3 to the minus 5, 3 to the 5th, right? And what does that exponent down there, negative exponent, do there? It moves it upstairs. So that's 2 to the 4th over 3 to the 5th. Now they didn't take that the next step and say what 2 to the 4th was and what 3 to the 5th was. Thank you very much for not doing that, but we could have done it, but we didn't. Let me get you marked here. Is it Somalia? Okay. All right, good deal. Okay. We didn't do this one. What is 4/5 to the -3rd? What would you do? 5 over 4 to the 3rd, exactly. You flip both of them and then just drop the sign of the exponent. Okay? And you could work that out. 5, 25, 125, 625, and whatever the next one is. That's too big for me to do. Okay. Oh, I did too many. It's 3rd. 5, 25, 125. So that would be 125 over 4, 16, 64. 125 over 64. But they didn't do that then, so you don't need to. Yes, they just say rewrite losing the negative exponents. You don't have to evaluate unless they tell you evaluate. Now, if the answer key gives it to you, go on and do it, but all right. Now, remember, after everything they do here, on most pages, now page 882, there was nothing in the gray marginal problems, but 883 there is, so do those in the margins, okay? I think we're ready. Yeah, that was the top of page 884, so let's do, here's another caution, okay, be careful. They've skipped example 3 altogether. Didn't they? Let me just go back and make sure we didn't. Now, there was example 2. Boy! Oh, there they finally get to example 3. Is that the same type thing as this example 3? I think not. Okay? So we're going to have some more example 3s coming up. Okay? We did this one. Right. Okay. Now, here's a caution. Actually, before the caution, let's do example 3. They're skipping some stuff here, so I'm going to, okay, clear the slide here, and we'll do example 3 here. Now, this is from the book. This is example 3 from the book. Changing from negative to positive exponents, simplify, assume that all variables represent non-zero real numbers. Notice on this one, they do say simplify, okay? So here's where they start. 4 to the -2nd divided by 5 to the -3rd. What would you do as your first step to simplifying that? Say again? Okay, you're going to flip them, kinda, right? So what's on top? 5 to the +3, and on bottom, 4 squared. Now, I think you know what 5 cubed is, right? 125. And what's 4 squared? 16. There we've actually evaluated it as well. Now, did they do that? They said simplify. They didn't say evaluate. They said, or you can go on one more step. Okay? So B, that was the A. This is example 3. Okay? B part here. M to the -5 over P to the -1. What would that be? P is on top. P over what? M5, okay? That was the special security decal in the British Empire. No, that's something else. Okay. P over m to the 5th. Perfect. C here, that was B. C here, okay, is a to the minus 2 b over 3d to the minus 3. What in the world would that be now? The b is in this problem, the 4 was not. What would it be? Second? Okay, I don't see anything being multiplied. Well, it sort of is, but they're not cross multiplied. You may be saying the right thing, but it's wrong terminology. You tell me what to write down. B. Okay, it's just B. There's no exponents for B. B. A little louder. Okay. Okay, dividing line. 3 stays down there. Second? A squared goes down there. Where does it go? It goes upstairs with the B. D cubed. Does everybody see that? Okay. The things without negative exponents stay right where they were. The B stays upstairs, the 3 stays downstairs. They didn't have negative exponents with them. Those with negative exponents flip across the line. The a squared, a to the minus 2 up here becomes a squared down there. D with the minus 3 down here moves upstairs and becomes D cubed. There's your answer. Okay? Now, does it matter? Could you have said D cubed D cubed B? Yeah, you could have, but it doesn't matter. Why would you? But you could. Okay? That's B D cubed over 3a squared. All right? Now here's D. X over 2y, and this is raised to the minus 4th power. What do you do with that? What do you do with a drunken sailor? Never mind. Okay. Second? 2y in the numerator over x, parentheses, 4th power. Okay? Now let's take it the next step. It says simplify it, so let's simplify. Okay, now it depends on how you said that. You said 2y to the 4th power. Did I hear parentheses in there or not? Say yes, I did. Oh, yeah, it's good, yeah. It's 2y to the 4th over x to the 4th. That's absolutely correct. You have to do the entire, because they're in parentheses there, they stay in parentheses. Now, what's 2y to the 4th? A little louder. 2 to the 4th. Y to the 4th over x to the 4th. And what's 2 to the 4th? 16. 16 y 4th over x 4th. Perfect. Way to go. All right. So there we have example 3 from the book. They didn't have it on the slide set. They will have one later, but it's going to be equivalent to something else in the book. So there's the example 3 from the book. Then they had not this caution, not that blue box, but this caution. Be careful. Always be careful. We cannot use the rule a to the m, minus m, b to the minus n. Okay. That change to this we can use. This is correct. Move the b upstairs to lose the minus, and move the a downstairs to lose the minus exponent there. That's correct. Okay? We cannot use that rule, which is correct, to change negative exponents to positive exponents if the exponents occur in a sum or a difference of terms. Okay? Now, you tell me what that means. 5 to the minus 2 means 5 to the minus 2. 1 over 5 squared, which is 1 over 25, plus 3 to the minus 1, 1/3, okay? 1/25 plus 1/3 over 7, that stays the same, minus second. Okay, there's the minus here. Okay, not yet. No, you can't do it if it's part of this. That's what they're saying. That's the be careful part. You have to do this just where it is. 7 minus 1 over 2 cubed. You see? Leave that alone. And that's exactly what they have here. 1 over 5 squared plus 1 over 3 divided by 7 minus 1 over 2 cubed. You already said that was 1/25 plus 1/3. You're going to have least common denominator. That's going to be 75, and fiddle around with that. 7 minus, and what is this? 1 over 2 cubed? 1/8. So that'd be 7 minus 1/8 would be 6 7/8. Okay? Or figure out what improper fraction that is. Okay? Now that's only writing it with positive exponents. You haven't evaluated it yet. So let's do it since it's so much fun. Okay? This would be 1 over 25. You already told me that. Plus 1 over 3. We already said that. This is 7 minus 1 over 8. Now, I just said one way of doing it. Least common denominator here, and fiddle with that, and 1 here. I'm going to tell you another way, and for this problem, it's going to seem pretty horrendous maybe, but it really is the easiest way to do this. Look at all your denominators and find the least common denominator of them all. And that's going to be a mess. That would be 25, 8 would be 200. Would be the least common denominator between those. 3 won't go to 200, so it would be 600. And then multiply every one of those by 600. So it does get to be an enormously large and difficult number. But it's the same thing you're going to get if you do them individually. This is going to be a 75 here, and then you'll have 3 here and 25 up there, and 3 plus 25 is 28. 75ths divided by whatever that is. 56 minus 1, 55 eighths. And then by the time you do that calculation, you get the same really big numbers. So let's leave it alone and not do it. Say we did. Okay. All right. So for now, if they just say rewrite it using no negative exponents, that would be it. Okay? Now, objective 3 is what we're starting now, and this is the quotient rule for exponents. Okay? And I was thinking we had already done this. I think y'all were thinking we had already done this, but they're acting like we haven't, so let's do it. For any non-zero number A, because you can't have A and 0 in the denominator. A cannot be 0. It could be if it just lived up there, but it's living down here, it can't be 0. A to the m over A to the n is A to the m minus n. Okay? Now why is that true? A to the m would be A times A times A times A times A times A. However many A's m is. And A to the n would be divided by A times A times A, as many A's as n is. And then if you canceled out all the n's into the m's, and you had any left over, that would be a to the m minus n. Keep the base, subtract the exponent. Hasn't we already done this before? I guess we did it with numbers, maybe, but maybe not with variables. I don't know. Seems like we'd already done this. So what would be 5 to the 8th divided by 5 to the 6th? Say that again? To the what power? Second, okay. And that would be 25. Perfect. Perfect, perfect, perfect. Way to go. Okay? So let's do a few of these. I think we have a caution next. Here's a caution. A common error is to write, oh no. Don't even write this down. No one, yeah. Forget that. We don't do this, okay? That is not at all the thing. Yeah. You have to deal with the exponents first before you divide. Remember, please excuse my dear Aunt Sally, deal with the exponents first. Keep the base, subtract the exponents. That would be 5 to the 8th over 5 to the 6th. 8 minus 6 is 2. That would be 5 squared. Now, if we were to write this down, this would have been 5 times 5 times 5. 5 times 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 5. That's 8 factors of 5 divided by 5 times 5 times 5 times 5 times 5 times 5. 6 factors of 5. These 6 will divide out those 6. 5 over 5 is 1, 5 over 5 is 1, all the way, leaving you just 5 squared, which is 25. Okay. So I don't even want you thinking about the other one. I want you seeing it. I don't want you to be imprinted in your mind anywhere, because that was totally wrong. Okay? Now, their example 3 is the book's example 4. I mean, it's not the same, but it's close. Okay? So what in the world would this be? 3 to the 4th divided by 3 to the 6th. A little louder? Okay, 3 to the negative what? Second power? Perfect. And what's that? 1 over 3 squared. And what's that? 1 over 9. Perfect. Okay? And actually, when I look at this, I picture all those factors of 3 there, 4 factors of 3 up there, 6 factors here, and divide out those, and you're left with 2 factors down here. That's 1 over 3 times 3 is 9. Okay? Now, let's see how they did that one. 3 to the 4 minus 6, which is 3 to the minus 2, which is 1 over 3 squared, which is 1 over 9. They didn't do it the last step. Okay, how about this one? Y to the minus 4 divided by y to the minus 9. What would that be? Y to the, not quite. Take a step at a time. Don't try to swallow the whole elephant. Negative 4 minus a negative 9. That would be y to the minus 4. What's minus a minus 9? Plus 9. And that would be y to the 5th. Okay? Don't take too many steps at once, especially if they lead you to error. Okay? Take them gradually. And sure enough, that's y 5th. Seems a little bizarre, but it's true. Now, the other way you could have done this is get rid of the negative exponents first. So what would that have given you? What would have gone below the line? Say again?
Can you repeat the question?
Huh?
Can you repeat the question?
Okay. If you got rid of the negative exponents to begin with, and rewritten this without negative exponents, what would have been below the line? Y to the 4th, because the minus exponent sends it downstairs, right? And what would the y to the minus 9? Where would it have gone? Upstairs. That'd be y to the 9th, lose the negative sign. And what does this give you then? That's pretty obvious then, right? Right? Maybe not. Y to the 9 minus 4 is y to the 5th. So you get the same thing either way. Frankly, I kind of like this better because when I'm subtracting negative exponents, I have to remember to change signs and add, that kind of stuff. There's just more potential for error there. This way, it's pretty straightforward, right? But either way you see it, whatever you see best, go for it. Okay? So there's example B. Let's see how they did it. Okay? They did it like we first did. Y to the minus 4 minus a minus 9. You subtract, you keep the base. Anytime you're dividing same bases by different exponents, keep the base, the numerator's exponents minus the denominator's exponent. And minus of the sign number, a negative number makes it positive. That's y to the minus 4 plus 9, y to the 5th. Okay, let's see if there's a C. Yes, here's a C. Well, wait. It was example 3 on that slide. It becomes example 4 on this slide, which gives us back to the right number. I don't know what they're doing here. All right. Let's do that. Ooh, boy, what do we do with something like this? Say again? 2 to the what? I can't hear. Negative 1. How did you get that? Four. Oh, this is in the denominator. Minus a minus 5. Right? Huh? So that becomes positive 5. 4 plus 5 is 9. 2 to the 9th. Okay? Okay, times z plus a to the first power. Now, I don't want to figure out what 2 to the 9th is. You could, you know, but that gets to be a mighty big number. I'm just going to leave it like this and see what they say. I may have to erase it, though. Let's see. No, they did it right. All right, 2 to the 4th divided by 2 to the minus 5 times z plus a divided by to the 7th divided by z plus a to the 6th. Okay, so that would be 2 to the 4 minus a minus 5 times z plus a to the 7 minus 6. That would be 2 to the 9th times z plus a, just like we did. Got it? Okay. Here's a D. And I think they have at least a D too. So let's do this one. What in the world would that be? Where would you begin? Say again? I'd start with the 5. It stays right where it is. It's just the number to the first power, stays there. Now let's look at our other number before we go any further. It's in the denominator, but it's a 3 to the minus 2. So what does that become? Say again? Yes, it moves upstairs and becomes a 9. It becomes times 3 to the 2nd, which is 9, so it's 5 times 9. Okay? Now, what happens to our x's here? X to the 4th stays where it is, but what happens to x to the minus 3? It moves downstairs and becomes x cubed down there. Okay, y to the 8th stays y to the 8th upstairs, but then what happens to y to the 6th? Second? Yeah, since it's the same y, you can subtract the exponents like that. Now, you don't have to. We didn't quite do it that way, but you could have. Because these are all positive, just do y to the 6 minus 8. That's going to be a y squared. This one, if you pulled this up, that would have been an x to the minus 3 minus 4, which would have been a minus 7, which moves it downstairs, which becomes x to the 7. So I like to take the negative number, and if you have a positive and a negative, take the negative and move it with the positive. Okay, if it's upstairs, downstairs, do that. If you have two positive numbers, then move the smaller to the larger. Okay, if you have two negative numbers, you do the reverse, move the larger to the smaller. But we didn't have that one. So what is our final, or at least an answer here? 45 y squared over x to the what? I couldn't hear. Okay, when you're multiplying same base, different exponents, keep the base, add the exponent. 4 plus 3 is 7. Okay, be careful on that. So let's see what they got. This was example 4. Oh no, that's on our slide. Okay, so let's see what they did. Oh man, they wrote over mine. Shame on them for doing that. Okay. Okay, they separated out the numerical parts, 5 over 3 to the minus 2. They separated out the x variable, x to the minus 3 over x to the 4th, and the y variable, y to the 8th, y to the 6th. Okay, on the numerical part, what we did in one step, they do it in 2. They bring this upstairs and make it 5 times 3 squared, which is what we had. And this one, they moved the x to the 4th upstairs and made it x to the minus 3 minus 4, which gives you x to the minus 7. Later we'll get there. And this is y to the 6th minus, divided by y to the 8th divided by y to the 6th is y to the 8 minus 6, subtracting your exponents, just like they did with the other two, are almost the same. And that would give you 5 times 9, x to the minus 7, y to the positive 2, and then to not have a negative exponent, we send the x to the minus 7 downstairs to make it x to the 7th. Leave this 5 times 9 is 45, and leave the y squared upstairs. There's the answer. I hope that's what we got, wasn't it? I believe so. Okay. Now, that was through D. In your text, example 4 gives you an E, an F, and a G. Let's do those. So E. This is nothing too new here. 3 squared x to the 5th over 3 to the 4th x to the 3rd. What would you say to do with that one? Well, a lot of silence here. Frankly, what I would do with the number part, in fact, it's what I like to do with all the parts. I like to move the smaller down with the bigger, or up with the bigger. I always like to do that. And including the signs, you know, a negative 3 is less than a positive 2, you know, so. But this is a 3 squared up here, a 3 to the 4th down here. I know that that would be, if you divided these two out with 2 of these, you still have 2 3s down here. 3 times 3 is 9. So you're going to wind up with a 9 in the denominator, okay? That's your numerical part. Nothing in the numerator or 1. But what do we have in the numerator? X to the 5th divided by x cubed. What would that be? X squared. There's your answer right there. X squared over 9. Okay? All right. Or x squared over 9, or 3 squared. All right. Let's try to do their F here. Their F is m plus n to the minus 2 power divided by m plus n to the minus 4th power. What would you do with one like that? Where would be your starting point? There's several ways to do it, too. So choose the way you see best. What's that? Oh boy, I was afraid someone was going to say that. You could have it now, they even have negative exponents. I wouldn't try to expand them with negative exponents. But what could you do? I'd say first let's get rid of the negative exponents. How would you do that? There's a couple of ways, again. Say again? Flush them? Oh, flip them. Okay, now that is one potential way to do it. That would be an m plus n to the what? 4th over m plus n squared. Okay. Okay. 4 minus 2 is, so, yes, sir. Oh.
Yeah. Sorry.
Oh, no problem.
I love the message. They want to know if it's okay for Cengage to come and
Say this again.
They want to know if it's okay for Cengage to come and do a presentation on Wednesday at 10:30.
10:30?
Yeah.
Where? This campus or the other one?
I think it's this campus.
Okay. Okay. It says 098 and 097. Is that math?
Yeah, the math.
Okay. Why were they sending it to Miss Hatter then? She's biology.
I think she related.
Oh.
Yeah.
She wanted her students to go to it. Oh, she sent this to you.
To me.
Or to me.
To you.
To me. Okay.
To you. She's asking you, but to me.
It's fine with me if they do it. I can't. Let's see. Wednesday at 10:30. I'm in calculus class then, so I can't do it, but it's fine if they want to have them. Okay.
I'll let them know.
Okay, great. Thank you.
Sorry to interrupt.
No problem. Okay. All right, and as you said, here's the same base, m plus n. Subtract the exponents. 4 minus 2 is 2. Okay? And that is I really like it. You chose a way that you saw what was going on. You could have done the same thing right here and done a minus 2 minus a minus 4. And what would that give you? 2 again. So you could have gone straight from here, but if you didn't see that, if you didn't like doing sign numbers, if when you subtract sign numbers you tend to make mistakes, which I notice people do, I do, so flip them. Get rid of the minus exponents, and then it's really easy to see what the answer is. So you do the way that you see best. Be sure that all the steps you take are legal in most states. Okay? Very good. That's number F. And that's what they got. And they do put another little thing on it. M cannot equal negative n. Of course it can't, because that would then make your denominator 0. Okay? And here is their G. Their G here is 7 times x to the minus 3 y squared over 2 to the minus 1 x squared y to the minus 5. Okay. What would you do on something like that? Hey.
Quick question. Are you going to be on Birmingham this Friday?
No, I've got thought I left you a message. I have an infusion Friday.
Okay. What about I'm just trying to set up a Friday for Cengage to come out.
Oh,
and do
okay.
a presentation.
Okay.
Now, they can come down here, but I know Friday, because I need the whole map team there.
Okay. Yeah, the following Friday, let me think. I should be here. I can't think of any reason not to be.
I think that would be the 20th, somewhere around there.
Yeah. Oh, yeah. Now, could you have it in the morning?
Yeah.
Because I'm supposed to leave to Georgia in the afternoon. I've got to drive
yeah.
over to Georgia that afternoon.
Yeah, we
So-
can meet and set it at 9.
Okay, now Darlene may not be able to be there because I think she has a Monday, Wednesday, Friday class,
Oh, okay.
9:30.
Well, I tell you what, why don't you send just an email to everybody? Because they can come in today. It
Right.
doesn't matter. So they can come,
Is that what this message is about here? Dr. Bryant just gave it to me, and I guess it was from Miss Hatter.
No, that was for the meeting today.
Oh, that's today.
Yeah, that was for today.
Okay, but it says on 098 and 097. Is that
It
math?
was just for today with Cherie at 1 o'clock.
No, it says Wednesday at 10:30.
I don't know. I ain't seen that.
Okay, I hadn't either. It's
Yeah.
Cengage.
Oh, I ain't planned anything with Cengage on Wednesday.
Okay, all right.
But
So
I
that's how-
told them I had to let you dictate when they could come.
Right.
But see, they have the 098 100
Right.
component. Then they have like a workbook
Right.
that they already have generated, where they have the sections that you can rip out, send back. So they send in books. I told them to send me about 9 copies for y'all to get one.
Right.
But I just need you to let me know when you want them to come out and do a presentation. They did one last Friday for Tracy,
All they did.
and they went through the mine tap and well sign.
Yeah, we were up at watching the club.
Right.
We were
Yeah, I know.
down there. Yeah.
So if you just talk with your team and whatever fits your schedule, because I think Jerashi said next Friday she wouldn't be there. So but it has to be on. It could be day or evening, whatever fits y'all schedule.
Evening on Friday does not fit mine.
But I know you said Darlene had class, and I know it could be after she get out of class.
Okay.
So but just email me and let me know.
Okay.
And I can set it up whenever you think.
Okay.
Time
If you will, check with Darlene and see either what time, if she'd want it before her class or after her class, and what time after her class would be.
Okay.
Yeah,
And
because
then that way we can do it on the 20th, then that's okay.
yeah,
Okay.
it's just I have to leave in the afternoon.
Oh, that'll be fine.
Yeah.
Okay. Thanks, Doc.
Thanks.
Sorry to interrupt.
All righty. Is there anybody else out there? Okay, just kidding. Sorry, folks. Okay. Okay. What would we do on one like this? Second? What about, is that victory? No, okay. What's that? I can't. Still. Okay. Just draw out the dividing line. Is that what you said? Yes, I like that. Good way to start. Where? Up or down? Up. And let's leave the 7 up too, right? Okay. So 7 times 2. I like it. Next. Or you want to do a little bitty dividing line, just having those over it. Or you want to keep it up. Okay. What else? Okay, leave the y squared upstairs and bring the y fifth upstairs. Is that what you said? I like that too. What's that? No, I think it's a 2. My pen sometimes drags, and you're making fun of my writing again. Okay, I understand. It doesn't really hurt my feelings too much, but I can live with it. Okay. All right. Next. Yeah. This x squared needs to stay there because that's a positive power. This one, minus 3, needs to go down there with it. So that would be x squared times x cubed. All right. Now let's Straighten all this mess out, and what do we have? 14 to the 7th over x to the 5th. Done! Okay. Does everybody see how that works? Okay. Let's see how they did it. Oh, look at that. They probably messed around with it. No, actually, they did it very, very similarly to what we did. Okay? Remember, there's many ways to get there. And what I said before, I like to look at exponents, and if it's a positive exponent, leave it where it is. Negative, move it to the positive. Here we had a positive down here, negative up here. Move the negative down to be with the positive. Here we had a positive here, negative here. Move the negative upstairs. Now, if this would have been a positive and a positive, then move the smaller one down with the larger one. If that would have been a positive or a negative and a negative, actually you still move this down because negative 2 is greater than negative 3. So, no. It worked out fine. Okay? Any questions on that? That was example 4 from the slideshow, augmented with 3 from the text. You still have the first, how's that many of that? 4 of them from the text you can work on, and all the ones in the margins to work on. Okay. I think we come to some conclusions now. Let's see if, here we go. Here are some reviews, okay? Definitions and rule. Product rule. You have the same base multiplied with different exponents, or even the same exponents. Keep the base, add the exponents, right? Okay. A 0 exponent is the value 1 as long as that base is not 0. If the base is anything other than 0, then that base to the 0th power is always 1. Okay? Negative exponents. If you have a to the minus n, move it downstairs and make it 1 over a to the positive n. If you have the same base dividing with different exponents, then a to the m divided by a to the n is a to the m minus n. As long as your a is not 0. It can't be 0 because you couldn't divide by it in the first place. Now, a little bit of a timeout here. What if m and n were the same? What would you have? A to the m divided by a to the m. What is that, by the way, folks? 1. Well, what if you use this rule? M minus m is? M minus m is 0. A to the 0 is 1. So you see, this one you can get from that. You don't really need a separate 1 there, but you could get it there. Okay? Now, I won't do any more. Okay, here's some more power rules. A to the m raised to the nth is what? Second? A to the m times n. You multiply. When you're raising a power to a power, drop down and that's multiplying the powers. Okay? How about AB to the m? That's the same as A to the m times B to the m. How about A divided by B to the m? A to the m divided by B to the m. Of course, B can't be 0. It can't there, it can't here, it can't anywhere. What would this one be? A to the minus m over B to the minus n. Okay, you can move the B upstairs, B to the n, and move the A downstairs, A to the m, and there you have it. Of course, the B can't be 0, or else that would be wrong. The A can't be 0, or this would be wrong. You can't do either one of them. What is A over B to the minus m? B over A to the positive m. Perfect, perfect. Y'all are good at this. Okay. So example 5 is going to do use a combination of the rules. Simplify each expression, assume all variables represent non-zero real numbers. What in the world then would be a cubed raised to the second power divided by what did I say? 2 cubed raised to the second power divided by 2 to the 6th. What's 2 cubed to the second power? What does that be? 2 to the what? 6 divided by 2 to the 6 is 1. Yes, very good. You can get that a variety of ways. Number 1, just the same number over itself is always 1. Or you could keep the base, 2, subtract the exponent, 6 minus 6 is 0, 2 to the 0th is 1. Always. Okay. I think I probably have to erase that, and we'll see what they get. That's 2 to the 6th over 2 to the 6th, which we know is 2 to the 6 minus 6, which is a longer way to do it, which of course we'll do it that way, is 2 to the 0th, and 2 to the 0th is indeed 1. So it can take up a whole page in what took us 2 lines. Okay. Good deal. Let's go for the B one. Okay. 3y to the 4th times 3y squared divided by 3y to the minus 1. What would that be? All your bases are the same, aren't they? And what is it? 3y. Okay? Now, what do we do with the exponents? These that we're multiplying, we add 4 plus 2, and that we're dividing by, we subtract minus a minus 1. And that would be 3y to the 6 plus 1 is 7. Now, don't think I want to expand it anymore. You could say that's 3 to the 7th times y to the 7th. And if you did on your calculator what 3 to the 7th was, you could get a number. I don't want to do that one, but you could if you wanted to, if you're really gung-ho about it. Okay, so let's erase this. Remember what we said. Let's erase it and see what they say. 3 to the 4 plus 2 over 3y to the 4 plus 2 over 3y to the minus 1. That's 3y to the 6 minus a minus 1, which is 3y to the 7th, which is exactly what we said. Okay? Which is 3 to the 7th times y to the 7th, which is exactly what we said. And please tell me that, yes, they do. I am never going to require you to do that, I don't think. Your homework may require it, but that is 3 to the 7th. Do you know how to do this on a calculator? I don't want you having it. You can do it that way. Here's the easier way. What kind of calculator do you have? Scientific or graphing? You have a graphing. Okay? Here's how you would do it. See if your calculator has this. 3, do you have a key on there that's a hat? That means raise it to the 7th power, and when you hit an equal, that should give you 2187. See if it does. Oh, you don't have it with you. Okay. Now, if you don't have a graphing calculator, you have an old scientific calculator, then you could do 3 and look for a key that says, which is it usually, x to the y, or a to the b, or b to the a, or y to the x. A key that looks something like that. Press the 3 first, press that key next, then press the 7, then hit equal, and you should get 2187. Start with something you know and see if you indeed get that. On the graphing calculators, they usually use the caret keys. On the other calculators, scientifically, they used to use one of those kind of keys. Which one? Depends on your calculator. I don't know. All right, so there is example B. Let's try C. Whoa! What are we going to do with that? And again, there's many, 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 many ways to start it. Okay, I saw him do a twisting motion, So what I think he meant by that is 2 to the minus, let me clean that up. That's the ugliest 2, okay? Okay. 2 to the minus 1, b to the 4th, over 5a to the minus 3. And did you want to do each of those to the second separately? Is that what you meant? Or 2 on the outside? You probably meant 2 on the outside, didn't you? Let's do that. Okay, that looks a little nicer. Okay. Okay. Okay, and do a 2 out here. Is that what you meant, right? Yeah. Flip these 2 just like they are, lose the minus sign. Very good. Okay, now what? Okay, on the inside, okay, leave the 2 on the outside here and just fiddle with these. B to the 4th is okay in the numerator, so let's leave it there. Except let's not change it. Okay. Something about the end of the day, things just start falling apart. The 2 to the minus 1 is going to go downstairs, but the 5 stays downstairs, so that's 5 times 2, right? And the a to the minus 3 needs to move upstairs, right? And become a cubed. You buy that? Okay. I like it so far. Now, can I just change that 5 times 2 to a 10? Okay. You said no? No, I'm sorry. Okay. Let's just change that to a 10. I just don't have as much room as you do on your paper. Okay, now what are we going to do? Just square everything. A cube squared would be a what? 6? No. 2 times 3 times 2 is 6. B to the second? You're multiplying. Raising a power to a power, multiply the exponents. That would be 8 divided by, and just do 10 squared. What's 10 squared? 100. Okay, yeah, that's what you want, isn't it? Okay. Everybody. Okay. All right. That, I think, is the answer that we should get. Now, I have a feeling they're going to take it a lot different directions and stretch it out, but let's see how they do it. Remember, A6, B8 over 100. Okay. Erase all that and see what they do. All right, they did exactly like Greg Joy said. They just flipped the inside and dropped the minus sign on the 2. Okay? And then they did exactly what he said again. They brought the a to the minus 3 upstairs, left the b to the 4th up there. They kept the 5 downstairs and moved the a to 2 to the 1st downstairs. They rearranged the order, but that didn't matter. And then they did as I suggested. A cubed squared is a6, b 4th squared is b 8th, and 10 squared would be a6, b 8th over 100. Very good. Excellent. Now that's the last one they do here for example 5. Okay? So let's go back and do D and E from the text. I don't think they're a lot different from what we've got here, but let's do it. Here's D from the text. So 3x to the minus 2 over 4 to the minus 1 y cubed, and that's to the minus 3 power. And there's several ways you can do it. You tell me which way you would like to do it. Anybody? Speak up. Say again? Lose the 3 on the top? Leave? Okay. He's going to deal with what's inside the parentheses first. That's fine too. It works just as well. 3 will stay on the top. Bring the 4 up, so times 4. Bring the x squared down because it's a negative. Leave the y cubed down because it's already positive. Okay, we haven't changed the thing, so that's a negative 3. Okay? Now what does that 3 times 4 become? 12. So I'm going to go on and multiply that if it's okay. Even if it's not, I'm going to do it. Okay? That would be a 12. All right, now what? Still need to deal with the negative 3. How do you do that? Second? I can't hear you. Factor it? Oh, I think I see what you mean. Okay, I wouldn't call it factoring, but I see what you mean. It'd be 12 to the minus 3, is that what you mean? Over x squared to the minus 3 times y cubed to the minus 3. Okay? What does that do for us? Second, flip it, okay? You could have done that up here. It's perfectly fine doing it here. This will be an x to the 6, y to the 9th over 12 cubed. And if you want to pick up that on your calculator and see what 12 cubed is, it's 144 times 12. I don't want to figure out what that is. Whatever it is, that would be fine. So that's one way. Or, if Greyjoy were here, he probably would have, at this point, had to flip them here and lose the minus sign. That would have been x squared times y cubed over 12 cubed, and then x 6 y 9 over 12 cubed. So either way, it's perfectly correct. Every step you took was right, and they actually multiplied it out and got 1278. 12 cubed. Fine with me. I don't know what it is. x6 y 9th over 12, 1728. Okay? Let's do E quickly. Okay. For m to the minus 3 over 3m to the minus 4. What would that be? And second, flip and see what you get. And that would be, okay, I went to flip and I wrote the same thing down, which is not flipping. Okay, 3m to the 4th over 4m to the 3rd. And then that would be that would be 3 to the 4th, m to the 4th over 4 to the 3rd, m cubed. And 3 to the 4th, 3 times 3 is 9. Do that again, you get 81 over, and 4 cubed is 64, and m4 divided by m3 would be m. There you have it. Pretty easy one, that one. 81m over 64. And you can write it either way. That's written with a fractional coefficient. The other way is 81m over 64. That's the way the book wrote it. Either way is perfectly correct. Let's see if we can get the notes in here quickly. Note, since some steps can be done in several different orders, there are many equally correct ways to simplify expressions like those in example 5. I've already been saying that over and over and over. Now, there's a few more of example 5 you can do in the book. There's all the marginal example 5s you can do in the book. And that leads us to the exercises at the end of 3.5. And you can do any of the ones 1 through 8. You can do any of the ones 9 or 10. Those are matching. Those are pretty fun to do. Any of the ones 11 through 20. Any of the ones 21 through 34. Any of the ones 35 to 58. Any of the ones 59 to 74. There's either 75 or 76. I don't really like those too much because they give you wrong answers and ask you what went wrong. So if you want to sort of skip those, you can. And then some summary exercises applying all the rules for exponent. Any of the ones 1 through 8. Any of the ones 9 through, goodness gracious, 9 through 50. I do some of each. And we'll begin next time with 3.6. Now, I think I promised you last time I would try to have your quiz done, and I finally did get it done today. But sorry, I forgot about this when Greg Joy was leaving. Do any of you see him? Any other classes? Okay, if you do run into him, tell him I had a quiz I forgot to give him. Okay? So, but it's all right. Y'all are going to have plenty of time to do this. But let me see how, goodness gracious, hold it up. Okay. Okay, thank you. That's one, keep one. I probably have another quiz for you too. Okay. Yeah. No. You were begging for it, so you got it. Okay. All right.
I'll take the 300.
What's that?
I'll take the 300.
Okay. Let's see. Your quiz 2, I think you don't have. And you'll need to come in sometime and make up the first test and the second test. Okay.
I'll be trying. My schedule is there.
Okay. Here's your unit 2 quiz. What, did I give you 2?
I think I just
Oh,
handed
sorry.
you this one.
What's that?
I think I just.
Oh,
gave you this one back.
oh, okay. I wasn't looking. I thought those were the 2
This
from
is
chapter
the one I
1.
just gave you back. Where is it?
Yeah, unit 2. Yeah, you already did that. Okay. All right, good deal.